Today, we'll discuss the 4 key Mermaid diagrams that software developers should know about. So first, the importance of technical diagrams. Diagrams are an effective way to communicate technical concepts to other engineers and business stakeholders. They even help me personally better understand the technical concepts while I'm creating the diagram. Effective senior engineers frequently use diagrams in their documentation and presentations. So as you're moving up the engineering ladder, you have to know about diagrams. Now, what is Mermaid? Mermaid is a popular JavaScript-based diagramming tool that allows anyone to create diagrams using simple text-based syntax. And I recommend starting out with a sample diagram in mermaid.live editor. And if you go to sample diagrams, there's a few sample diagrams here. And you can go ahead and edit this diagram and see the changes. But first, let me go over the key reasons why Mermaid is popular. First of all, it's text-based, right? So it is easy to write. You can quickly write all this text and create this nice diagram. It can be version controlled because it's just text. So if there's a change to 1 line or 2 lines, you can see it and you can easily see what the difference is. It is integrated with Markdown, which is widely used in documentation and static site generators. By integrating, sometimes you may need to explicitly add the Mermaid library, but it's pretty straightforward. GitHub and GitLab use Markdown, and you can use diagrams, Mermaid diagrams, pretty much anywhere. So here I show a Markdown file, and I can just go to GitHub, go to this file, and I see Mermaid diagrams being rendered here. So if you're using GitHub or GitLab, Mermaid diagrams are the way to go, as opposed to hiding your diagrams in some proprietary tool. Versatility. There's multiple diagram types, from flowcharts and sequence diagrams to ERDs, which I'll go over shortly. And it is automation friendly because it's text-based. You could generate diagrams programmatically. For example, you could always have a diagram of your database schema being generated every time you run your CI/CD pipeline. And it does not require specialized software. You can just get started, like I said, in GitHub or GitLab, or with just pulling in the Mermaid JavaScript dependency. So in our experience, these diagrams are simple enough that you can even use them ad hoc instead of using, the proverbial pencil and paper approach. Like, you can actually, instead of drawing, you can actually use the text to generate a diagram. All right, so let's get started with the first one. First one is a sequence diagram. So I'm going to go ahead and just type one out. So suppose I'm in a meeting. I want to explain something. So I quickly display Mermaid Live and I type this out. Sequence diagram. So that's a type of diagram. Typically, you indent next lines. So I say UI to MDM server. Upload profile. And as I'm typing, you see the diagram being created here on this live editor, which is pretty handy. And then from MDM server, we have an arrow to Apple because we will request a push notification. From Apple will send that push notification to a macOS computer. And this macOS computer will in turn go to our MDM server to request the next command. And the MDM server will send the install profile command. So just in a minute or so, I created this diagram to demonstrate a concept. And for many use cases, this is all you need to know to create a sequence diagram. One reason we like them is because they are consistent, right? They always kind of look like this. You got columns and you got arrows, so there's always a consistent view. There's none of this, moving things around based on how many things connect to what. So it's really nice. This is our favorite type of diagram. Now you might want to pretty this up, and I'm not going to go through everything, but one thing to know, and this applies to many diagrams, is above the diagram you could add a title. Title my diagram. Changed it. Interesting. There we go, and this shows up here. Whoops, up here. So for sequence diagram specifically, I would go to the sequence diagram documentation, and there's a few things you might want to do. I'll go over the key ones. Actors, you might want to have a person picture, in which case you need this syntax. Alias, so sometimes you have, like in my case, I have MDM server, kind of long. Maybe I just want it to be called MDM, but I still want MDM server up here in this box. So that's called an alias. Participant J is the short version, as John is the long version here. Responses, so different arrow types. I don't recall exactly where in the documentation that is, but basically different arrow types. Like over here, a response, dashed arrow with a solid arrow, and then you have like an demonstration, an async, which is, let me search for that syntax, is dash 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 close parentheses. Here we go. Dotted line with open arrow, then async. Typically used for async async messages. Activations, deactivations. So you might want to have this box for like clarity of your diagram. So you can do this like this: activate, deactivate. There's also another syntax, but the syntax up here is more consistent because you might be having multiple activations, deactivations going on, and using this plus and minus syntax could get confusing sometimes. So for clarity, for our example, I'm going to use this. Loops, alternatives, and parallels. Basically, these are just like a box that happens in the diagram. Alternative has different alternatives. Alternative is sick as well. I guess there's also kind of an optional here. Parallel, another box. Basically, all of these are just boxes. The different letters up in the top left. And auto number, useful for discussions, like you're in a meeting discussing big diagrams, and someone can be like, okay, the number 11 is doing something this. They may have a question about something specific, and it's good to have numbers. And adding notes, where is that? Something like this, note to the right, note spanning, note over, note to the right, note over. So those are the keys, and I'm going to go ahead and just copy paste a diagram just for demonstration purposes of basically an expanded version of this. So this is good for a quick and dirty diagram, but if I wanted to actually document something, I might want to pretty it up a little bit. So, I've got a person here, I've got responses, I got a note, I got like this example of, something happening internally. Yep. This is how it looks a little bit longer. I've got these activations going on here. Basically, that's what I added, activations, and then more responses. And a little bit more flushed out this bottom section over here. Okay, those are sequence diagrams. Next, let's go to flowcharts. Let me click this flowchart here. There we go, example flowchart. Okay, so flowcharts are graphical representations of processes, workflows, decision logic, etc. And they use standardized symbols like rectangles, ovals, diamonds. But basically, flowcharts are kind of a generic diagram that can be adapted to any purpose. And we often like them because we use them to explain technical concepts to non-technical stakeholders. So let's go ahead and just create one. Flowchart, admin, keep doing -- uses. What does admin uses? Uses server. An agent checks in with server. So once again, I'm kind of doing a quick and dirty diagram, something that can be done in a meeting. But in server accesses the database, which in this case is MySQL, and server also accesses Redis, and server uploads analytics. Where does it upload analytics? To dm.com. So there we go, quick and dirty flowchart. Basic generic concept that can be displayed to a business stakeholder. So this is kind of just like your generic block diagram, right? If we want to actually go and show a type of business process, it would look differently. So let me go ahead and just copy and paste a different one instead of typing everything out. Here we go, simple business process. And I'm actually using different shapes here. So first thing you notice is the diagram is going left to right. So you can have left to right, right to left, top to bottom, bottom to top. So I can change this to top to bottom, TB, and look like that. So you can kind of reorganize your diagram a little bit using that. I'll keep it left to right. As you can see, the syntax here for the oval is like this, process, and here process data is 2 lines, so you can actually split things, more stuff. Even this, can I do this? I can't do this. I think there's different syntax for that, but anyway, I'm just trying things out. And then I defined the items up here. So I have like the name and then what's in the box. And then I can, this S is kind of an alias, and I can refer to this S later in the diagram up here. Here are the key lines down here. It's a bit of a different syntax than I said before. Before I was using this syntax, -- some text, and this text shows up on the line, but you don't have to have text on the line. You can just use this line like this. Another example. So standard shapes. So we got the oval, you saw the oval, the syntax. We got the rectangle, this syntax. We got the diamond, this syntax, arrows, just like this, or like this if you want text in them. Parallelogram, which is oftentimes is input or output from a process, such as, feed in a text file or something like that. So for example, I can do, and you can, as you can see, you can put spaces in between for clarity, separate different sections of the diagram. So let's do data, and this is the parallelogram data. Data. Here we go. We'll send it into PD. Wow, that's interesting. You see, I didn't even need to type PD here. It already knows where it's going because it's going to the next thing. That's interesting. Cylinder for the database. So suppose this data was a database, so I would just change this to a bracket with parentheses, and it's a database. So it's kind of the opposite of the oval. Oval is parentheses, brackets inside. Database is brackets, parentheses inside. So those are the key shapes. Pretty standard. All right, let's move on to the third one, class diagrams. So a class diagram is one of the core components in the Unified Modeling Language, UML. and it's used to visually represent the static structure of a system. So traditionally, it models classes, their attributes, operations, also known as methods, and then relationships among the classes in the system. However, what we found is that the most helpful use case for class diagrams is to model relationships between higher level entities. So we like the class diagram because of the standard relationships it has, not necessarily because of the attributes or the operations you can add to the classes themselves. Of course, higher level entities, we can also use a flowchart, like you said, but sometimes it's good to have those standard relationships. So let's start with a simple class diagram. I'm going to start and then I'll fill in the details with copy and paste later. So I'm not typing a bunch, so I can just have a basic relationship here. Fleet manages hosts. And you see the syntax is simple, something I could throw together during a meeting. Fleet also may have policies, make it singular, checks main force. So these relationships, these lines with these special symbols, and that is what we like about the class diagrams. I'm going to go ahead and populate the rest of this class diagram, and then I'll go over the types of relationships we can have. And these relationships you can find on the documentations. So if you go to the class diagram and define your relationships, you can see the types of relationships we have. So let's start with inheritance. So it's a generalization. For example, car is a type of vehicle. So I'm gonna go ahead and I'll just delete all this and we'll just focus on the relationships here. So a vehicle, dash car. Now, similar to a relationship is a realization. So you see the syntax is kind of similar. Instead of that, there's dashes here, but realization is dots. So a realization is a more kind of generic. It's more of a kind of an interface class type of thing. So interface is implemented by class. Implemented by. And this inheritance is a relationship. Is a. All right, other relationships, composition. It's a strong relationship. For example, a car must include an engine. So car must include an engine. Engine, there we go. And then we have aggregation. It's kind of a weaker type of relationships. So for example, a school has students, but does not necessarily need to have students, right? You could have an empty school. Let's see, association. This is kind of just a generic relationship. For example, a user places an order. And you kind of choose which way the arrow goes in this type of relationship. Let's see, what else did we miss? Dependency. Something depends on something else. So for example, in order to have a payment, we must have an invoice. And there we go. Those are the standard relationships. What's going on here? Interface. This is dot, sorry. You got inheritance. We got realization. aggregation, association, dependency, and then the composition. Those are the main standard relationships. Now, class diagrams can also include data members and methods, but this amount of detail is generally too much to maintain in a diagram. So we recommend only adding this detail when presenting in snapshot or some kind of a proposal for new classes or change in existing classes. So we can just go to sample diagram, click on classes, and you will see this extra detail, right? We've got relationship defined up here, and it even shows you different types of syntax, right? You can use this syntax where you add each thing on its separate line, or you can use this kind of this different syntax where you've got the data members here and then your methods. I think the key here is methods and have parentheses in them. That's how it differentiates. All right, so now we go to the fourth type of diagram, entity relationship diagram. Let's go ahead and bring up a sample. And I actually like this sample because it is kind of generic. It just has the names and their relationships. It doesn't have the details. So this is actually a nice one that could be maintained. Generally, we recommend not using ERDs, entity relationship diagrams, as more of a snapshot or proposal type of things. But if you don't include any detail, the problem is the detail needs to be maintained. All the columns and types and things like that. But if you just got the names and relationships, they're a bit easier to maintain. And once again, the nice thing about these ERDs, they do have standard relationships. Just like in the class diagram, we had standard relationships. Here, we also have standard relationships. So let's show these standard relationships. And these are pretty straightforward. So you've got like one-to-one relationship. I missed an extra dash. One-to-one. One-to-one. There we go. You see it up here. Then we have zero-to-many. Dash, dash, O. O. I don't like the fact that it's creating a second bracket here, which I don't need. So zero-to-many. Here we go, zero-to-many. Then we have one-to-many. Dash, dash. And then we got vertical line like this. One-to-many. And then we got many-to-many. Dash, dash. Many-to-many. This looks right. What did I do wrong? Did I? Reverse them. Dash, dash. Here we go. Many-to-many. And I'll go ahead and just copy and paste a sample proposal that I created recently to show the additional detail you include. So in the previous example, we just had the names here, but here we got the additional columns. We got the name, the type, whether it's a PK or an FK, and then the last column is a comment. For example, in the skim groups, I got the name, the type, it's a primary key, and then I can add some comment. And that's kind of the what's going on here. And we saw the extra comments between the lines here, as in the previous example. And that's what they look like. And to get more detail, you can go to the documentation. And it's not that big. There's not that many things to entity relation type diagrams. All right, so I'm still learning. I'm still learning about Mermaid diagrams, and I will continue using them. And I hope you found this useful. I definitely recommend them, especially as you're moving up into senior engineer ranks.